Dear participants, welcome to the next session. Dear participants, welcome to the next session. Our speaker is ready. Today's topic is Internet of Vehicles. Our speaker is Mr. Kamal Kumar from Savari Systems, Bangalore. Now I request Dr. P. Nageshwar sir to introduce speaker to the participants. Welcome.
Thank you very much, ma'am. Myself, Dr. P. Nageshwar, introducing you the speaker of the session, Kamal Kumar Mukri. Sir, Kamal Kumar has obtained his MTech in DSP from NIT Rourkela in 2007. He is a technical trainer on C++, Python, Linux system programming, and IoT devices. He worked in Hawaii Technologies as technical lead from April 2011 to July 2017 and had an experience of 10 years. He has worked in the area of IoT, software development, and IoT training. He is currently working as a staff engineer at Savari INC. And he has got the technical skills in the following areas of programming languages, scripting, operating systems, networking, applications protocols, IoT protocols, and hardware and technologies. He has worked on distributed cache CDN, applications protocol traffic optimizer over WAN, mobile communications, data acceleration service for cloud and IoT, secure coding in C. And he has used the following tools of GDB, ptrace, GCOV, gprofile, Nmap, DUMP, Linux, Visual Studio, Family, Source Insight, and Git. He has got a professional experience as a trainer, and he has been a trainer for more than 20 programs on IoTs, Python at India's best institute like Great Lakes Learning, and he has been a resource person for several such workshops like what we are organizing today. Thank you very much, sir, Kamal Kumar sir, for accepting our invitation to act as a resource person. And now it's over to you, sir. Kamal Kumar sir, please take over.
Thank you so much, sir, for having me here. And I wish all good morning to all the participants here. And yeah, I'm going to share my presentation. Okay, now, could you please confirm, are you able to see my screen?
Yes, sir.
Okay, yeah. So, in meanwhile, I will switch off my video. Unnecessarily, it consumes data traffic. Okay, so so here, as of now, you have you had the sessions on IoT, and actually, it makes my life little easy to present this session. Okay, so if before I start, if questions you can raise, let us make it as a more interactive. But unfortunately, it is not like IoT session where I cannot present the real-time applications. But I'll try to be there in real-time systems. Okay, so I'll try to present the real-time applications and make more comfortable to understand. Okay, so so let's start the topic. So again, I'm telling you, if you have any doubts, please you can ask me. You can switch on the mic and you can ask me. Okay. Has anyone heard V2X technology so far? So it is V2X technology meant for vehicle to everything. Okay, let's say Okay, so these are the contents before I proceed. These are the contents. We'll be discussing about what is the need of V2X, the introduction on V2X. V2X means vehicle to everything, okay? And the technologies used in V2X, the hardware, a slight introduction on hardware, what hardware is being used currently in vehicles or infrastructures, and some attacks, some challenging points to deploy this VTX technology and to make it real. There are many challenges. Well, we should discuss about all that. Okay, so you can see the slide, right? Study by DOT in US, but this study is very old, 2011. When that time, actually this technology, people started thinking about there should be some hardware in the cars or in traffic signals or in like a bridges, like a flyovers. So if there are hardwares which can control the accidents, that would be better. So we as a human being, we developed a lot of things like mobiles or computing. A lot of advancements are there, but coming to traffic, there is advancement in the features in the car. Oh, luxurious features, it's too good. Previously, when you drive Ambassador, it won't give that much pleasure, but now the cars are there. It gives a nice pleasure. High speed, safety measures are there, but coming to how we advanced in traffic safety, like minimizing the accident, that actually we failed completely. Let's see, if you observe the data from 2000 till now, there is increment, there is a lot of increment in road accidents, but not decreased. Okay, so there should be a technology where it should control these accidents. Okay, so let's discuss the scenarios here. The first image shows that it's all this car, right, applied sudden brake and we go and hit. You might have seen or you might have heard about these incidents a lot. And the second image, it's like a road is not good. Chips are there, like maybe it is slippery, right? The car, the vehicle did not know that ahead there is a slippery road. And coming to the third image, it actually we might have seen so many videos in YouTube, a lot of places, mainly on highways. You can see these accidents. The other vehicle which is crossing, which is taking left turn, is not aware that other vehicle is coming. Okay, so and coming to the fourth image, the vehicle is coming very fast and it could not see, maybe it could not see the vehicle which is stationary. Okay, and the fifth image, it shows that, okay, car is coming on high speed, but the person, luckily he escaped here, but usually it goes over the person, right? So, but if the person don't see that vehicle, you could see the major accident, right? So the person is not aware that there is something wrong. Okay, so like these, so many examples are there. Like in US, there are stats in 2011, 5 million crashes, 30,000 traffic fatalities, 2 million injuries happen. It's a huge, actually. No, it cannot be accepted. With having, we say that, and US usually say that they are much more developed country, but still they have these stats and they cannot say that now. Right, so accidents can cause life loss or property damage, many things, right? So here you see, if you see the scenarios, it's a lack of communication between vehicle to vehicle. If this vehicle comes to know that there is vehicle coming on other road high speed, he could have stopped it. Okay, and if it is slippery, you could have slowed down your car, right? So this is happening because of lack of information. It's not, there is no much information, right? Coming to other examples, here you can see three images, three pictures. The first one is like maybe people are decent, they're driving well, but they do not know about traffic, the infrastructure. Okay, if you go to a new roads, new city, you'll face this problem. You do not know whether you need to take left turn, right turn, mainly at junctions. It's really difficult. Okay, and the second image, it looks a little funny, right? So the bicycles, if they come to know that it is not good to go in this way, they would have avoided this one, right? And the third one, actually, this bus could not see the toll gate. Okay, so this is all about, so the above one shows about if there is a communication between car to car, they could avoid these accidents. And the second slide, if you see that if car knows about the traffic or about the road or about the toll gate, it is there. It's not between vehicle to vehicle. It is between vehicle to infrastructure. Okay, so if we have that technology, it is good. We could have avoided so many accidents by now, right? So what is the solution for that? So, okay, before that, I just want to remind that no technology can save idiots, right? Here, if you see all these pictures, right, even if hi-fi technology is there, nobody can save them, right? So people usually say, okay, if there is a technology, if I switch off the hardware, what will you do? What will you do? Nothing. You'll not be saved. That's it, right? So before I proceed, just I want to present this one. Okay, what is the solution to have all that infrastructure? Obviously, automated vehicles, right? Or autonomous cars, you can say automated vehicles, automated connected vehicles. There are many terms. You can say automated vehicles. Okay, so automated vehicles, our assumption is like this: you sit in the car, or car is there at your home, and you asked your kids to get in that car, and you set the destination. So car will get your kids to your office, your colleague, your college. Okay, that is the thing what we assume, right? Automated cars means that is what we assume exactly. So if you see that in 2015 and all, many OEMs, many manufacturers, they told that by 2020, you can see automated vehicles on the road. But did we see now? No. There are a lot of challenges to make it real. I would say, our organization could say that to make this happen real, it might take another 10 years, might take another 20 years. There are so many challenges. We'll discuss it later. But should we wait for 20 years? Should we wait our car getting automated and getting all these features? No, we should not wait for 20 years, 30 years. We cannot let this accident happen. So there should be another technology. It's like one by one. You have another technology so that it can avoid some accidents. Okay, so if you see, automated cars are having LiDAR, camera, radars, ultrasonic sensors, onboard units. So many are there. If you see something here, here 802.11p. What is this? This is like our Wi-Fi spectrum. Okay, our Wi-Fi spectrum is around 4.8 gigahertz, right? If I'm not wrong. So it is gigahertz. Okay, so along with all this, why do we need this anyway? This is related to V2X technology. V2X technology is different from all this. You can say it is a part of automated vehicle, and it doesn't need all these sensors. Okay, it doesn't need all these sensors. Okay, let's see what is that. Okay, so coming to it's like our complete that final target is like automated car. It's like a completely featured. Okay, and before that, what the organizations came into the picture, brought up, there are some levels. So fifth level, you can say whatever you dream, you're dreaming now, right? That is fifth level. But you know where we are at level zero. I mean, level zero, whatever the vehicles we are driving on the roads or having level zero. Now we are striving a lot, we are struggling a lot to reach level one. Okay, so if you see this table, maybe after the session, I'll share the slide. You can have a look at. Here, car means car is having all the control. If you see the person, mean person should be there. Okay, so who monitors the road? Person has to monitor the road. Here, now you see, everything is done by human only. Okay, but level one, steering and acceleration can be partially can be taken over by car. A car means a computer which is there in the car. Okay, it is like if there is a hardware which can give some assistance to the driver, like ahead in after 1 kilometer, there is huge traffic you try to avoid. So maybe now you can use Google Map, but Google Map is not so accurate. Okay, for that you need internet connection, right? So and there are some problems also. Okay, so but with this technology, VTX technology, it's like a feature, it's like inbuilt in your car, so that you can get all the alerts. Okay, so internet is like you need to have a chip, you need to have a 4G connection, then you can get a data rate, and that data rate is not reliable. Okay, if you go in high traffic, maybe data rate will not be that good, and whatever the alerts you get will not be that accurate. Okay, so there should be some technology. So whatever we are concentrating, like VTX technology, connected cars is all about level 1 automation. Okay, so and it is much important for autonomous driving cars. Okay, so if you see, let's say that we to realize the importance of VTX technology, we'll see. We'll just have a glance on autonomous driving car. Okay, what are the sensors it is having? So you can see the sensors and its ranges. Okay, so the maximum range is covered by long range radar. Okay, so maybe it is around 500 meters, not even 500 meters, 100 meters, like that. It won't go beyond much. Okay, but if you rely on these sensors, how would you predict that? How can you predict that there is a traffic or there is a road accident ahead, one kilometer ahead? How can you identify that? It is impossible. And some cases I'll tell you where it can fail. So let's okay, so here can you see the picture here? Is it okay? Yeah, so suppose if any vehicle is coming from another other road, let's say it is our junction. I don't know what is a famous junction in Vizag, but let's say it is a famous junction, and the car is okay. You assume that car is coming in this direction, okay, and another car is coming in this direction. Okay, so here, if you check any sensor, either radar, lidar, or camera, nothing will work in this case because it is not visible. Okay, so it is not visible, and maybe it is visible when the car comes here. So when the car is here and this car is here, then that time it is visible. Even if you apply sudden brake or even if you accelerate, it cannot help you. You are going to hit the vehicle, definitely, right? So it is good to have, like let's say this is road, and your A is nothing but your car. Okay, so our host car, and B is there. Okay, so he is coming on high speed, let's say 200 kilometers per hour. So usually it and you're coming on little less speed, let's say 60 kilometers per hour. Okay, so if you maintain the same speed, definitely you'll go and hit the vehicle. Okay, and so let's say these two vehicles is around 500 meters away. Then if you get the alert, if the vehicle is around 200 meters away, which you are going to hit, then it is good. You can apply the brake or you can increase the speed. Okay, it will give you stop the car. The vehicle is coming another way, so you should stop the car. If you get that alert, it is good. But will these sensors serve in this? Can any of these sensors give this indication? Can they serve this purpose? No, it completely fails. Okay, so we need some other technology. How this technology works, we'll see that. Okay, so just this slide is all about that one, where it can fail. So far, is there any question? Is there any question that what are these sensors? You want to have some idea on this? So maybe mostly you might know very well about radar, ultrasonic, camera, and LiDAR. Maybe if you do not know, just take a glance. LiDAR actually gives a 3D map. Okay, so LiDAR, you can see this one. LiDAR, you can say like a rotating radar. Okay, so it revolves, it makes rotations I think per second it makes for several times, like maybe 10 times like that. So it always rotates. If you see autonomous driving cars, right, you could see that maybe in CM car, security car and all, you can see these kind of radars, okay, which is rotating. It always detects either bomb or something else. Okay, so here LiDAR is another sensor. It is like it gives you a 3D map, so it can sense there is a car in front of you and how far it is, what is the shape of that car, and surrounding sites also it can find. So it is little high, very useful, but very costly. A small LiDAR, a basic LiDAR sensor will cost around 10,000 rupees, not more than that, I think. Okay, so and camera, if you want high resolution, it costs a little more. Radars, so many sensors are there. Okay, and its cost is too much. Okay, why do we need to go for V2X technology? There is another reason. That is like if you want to have all these autonomous driving car features, it is very costly. Maybe it will be more than your car's cost as of now. Okay, but later on, while time goes on, it will not have that much cost, but it is costly. Okay, but whatever I am saying, V2X technology will cost around 5,000, 6,000, not more than that. Okay, so that is why people are preferring, okay, it is less costly and more effective. Okay, so it can serve many things. That is why all the autonomous, instead of waiting for autonomous, all car manufacturers are interested in this technology. Okay, so what is the funda in this V2X technology? Let's say just to create a curiosity, I want to let you know that elephants, right? Elephants, they communicate around 2 kilometers far. Okay, if there is any vehicle 2 kilometers far. If any vehicle elephant is there 2 kilometers away, then they can communicate using some signals. The frequency, right, is below what we hear or above what we hear. And so suppose there is a study, very interesting. If you are interested, you can click on this YouTube link. Maybe it is around 5-6 minutes video. It's really amazing. Okay, so they communicate and they identify, is there any danger, or if, let's say, if any lion or anything is there, they communicate ahead, so that they can avoid that. Okay, and also, you know, they transmit the waves in the ground. Okay, it's like when you stamp on the ground, right, it vibrates, right? So they also do that, but You can't sense that, but they can sense. And their feet, right, is a good sensor. Okay, so why am I saying all this? It is not inspired by V2X technology, but it is related to V2X technology. Like they know how to communicate from a little far, 2 kilometers, 3 kilometers. They told a few kilometers, but we can say at least 2 kilometers is good, right? So they can avoid some dangers, or if they are in some dangerous situation, they can send a signal to other elephants. They can come. They can plan and kill also, you know. So they are very intelligent in that sense. Okay, so our VTX technology works in similar way. Okay, so it's like our car. Show you. Yeah. So let's say if this is highway, all these cars, right? They broadcast. Just I want to emphasize. I want to elaborate what is meant by broadcast. What is, here is like suppose if two computers are connected, it's like unicast. We know the IP address. We send to only that machine. Okay, other machines cannot hear that. And broadcast is not like that. Broadcast is like you send the signal, but all other computers will can listen to that your message. Okay, like let's say WhatsApp group, we send the messages, so everybody can receive it. The similar way, cars also, they transmit the data, they broadcast their data. So where I am, what is my position, like a latitude, longitude, elevation means the height, and what is the car size, and all the information will be broadcasted for every 100 milliseconds. Mean every second they send 10 messages where I am. Okay, it's all like they broadcast. Okay, so like elephant, right? They can communicate. It's also like a broadcasting. Any elephant can sense that. Okay, like that, all the cars will transmit their position. Okay, so let's see, first of all, before we go to the technology, like let's see what are the advantages of VTX technology. So first thing is like these four are main. Okay, there are a lot, but these are all like a very major advantages, like accurate vehicle information. Okay, so it's like what is my speed, where I'm going, towards which direction I'm going, am I applying the brake? Okay, so all this information, right, will be accurate. Suppose if you use any of these sensors, lidar, camera, radar, any of these sensors, we have to run hi-fi algorithms to identify the opposite, what vehicle is coming and how much speed it is coming. But still, no algorithm can give better accuracy. I mean, with zero error. There will be some error. Okay, so with all these sensors, you still you cannot rely the data what you process. But these vehicles, right, V2X technology, I'm sending my data, right? So I know, suppose if sensor is there in your car, sensor means you know how much speed your car is going. Speedometer knows what is your speed. GPS should be there in your car. So this data, when you apply the brake, you get the data from microcontroller. So all this data can be broadcasted, and all this data is accurate. It's like I'm telling about myself accurately. But if you want to predict about myself, maybe you can go wrong sometimes, some cases, right? But if I tell about my details, so that you can completely rely on that, right? That is a funda behind this VTX technology. So accurate vehicle information and sensing abstractions, like I told you, right? If a car is coming in other road, and if you can't see that, VTX technology helps here. Works in all environment conditions. It doesn't matter if it is foggy or it is dark or it is raining, doesn't matter. It works reliably. Okay. And the traffic light state and timing. So this is very important while to manage the traffic in the city very well. Okay, so because your traffic signal, right? Even you have to see red and green colors, right, near the traffic signal. But coming days, maybe it will not take much time, maybe 4 or 5 years, you can see that in your car. Oh, there is a signal and it is in green color. And now if you maintain a particular speed, you will not get red signal. Or it will tell you that, oh, it is about to switch on red signal, so you slow down your car. All these applications will soon come into our cars. Okay. Yeah, V2X means, as I told you, that vehicle is communicating with the pedestrian, with other vehicle, with the smart home, with other devices, with infrastructure. Okay. Okay. Previously, it was started with a V2V. V2V means vehicle to vehicle. But later they realized, oh, this is really great. We can integrate that to infrastructure also, like a smart cities. We can implement for smart. You can use it for smart cities. You can save many pedestrians. Okay, so tomorrow if you walk on the road with your mobile while watching mobile, you may get alert. Hey, the car is coming. Stop here. So all these alerts can get, or car will get the alert. A person is crossing the road, slow down your car. So all this will be done, and it will happen very soon. Okay. So just I want to stop here. Any questions are there so far? I feel. Need any clarity? Okay, is it clear? Am I going fine or speed or very slow? You can give me the feedback right now. Okay, so I hope I'm going fine. So otherwise, you have to bear me. Okay, so you can raise the concern. If you have any doubts, you please raise. Okay, fine. So what are the applications of V2X? Maybe we can come back to this slide after some discussions, because time is little less. I mean, we can see after the session, you can go through these applications and you can relate it. You can understand it well. Okay. So fine. So coming to the applications. So I've been telling the applications, right? Few of the applications I can tell here. Let's say car, you can see the curvature. Okay. So this car can inform another car which is following that, hey, come little slow because it is slippery. Okay. So this car can sense and can communicate to this car saying that you come little slow. And you see that this scenario you might have seen many times. We might have regretted why people are not having sense at all. They are not giving way to ambulance. Okay, so if this technology is there, it's like ambulance will send you the indication from 1 kilometer before it reaches you. It can give you some signals. Hey, I'm behind you for 1 kilometer. I'm very important. Give the way, so that you can give the way. Okay. So another thing, like as I've shown here before, bike collision avoidance. Okay, bike is coming. Here you can see the bike definitely cannot see this car. So bike can get some alert, and also car can get some alert. Okay, bike is coming. You slow down the car. Okay, so all this collaboration, right, will happen. Okay, cyclist crossing the crossing alert. Like when cycle is crossing, you'll get the alert. When you try to take left turn, as if now you have to see the meters and all, right? So whether vehicle is coming from behind or not. Okay, so but once this technology can get you the information on your board. Okay, emergency braking alert. Like if you can see in second picture, the vehicle here applied certain brakes so that you will get alert, okay, so that you can apply the brake. Especially, this is useful in foggy days, like in Andhra also. Especially in winter days, you could see so many accidents in roads, all because of fog. But we can avoid this. Even if car is not available, not seen, you can get the alert. Okay, so, and traffic signal timing, as I told you that, okay, green signal is there, it will be there another 5 to 8 seconds. It's up to you. Okay, so intersection moment. So you can see the dashboard here. So many of trial versions are going in Europe, China, and the US. They have this feature, and they are trying all the applications. These are the pictures. Okay. And here you can see that here it is like this. So you can't see the vehicle which is coming opposite direction, right? If we try to cross this tank, then you're gone. Okay, it gives you that don't pass, wait for some more time. The vehicle is coming. Okay, many drive on vehicles, and if it is two-way road, this problem will be there, right? And so many applications are there. Yeah, so finally, how does it work? How all these applications work? We'll go one by one. Like, we know the importance of VTX and what all alerts it can give, right? What alerts it can give, but how so to make the alarms, what it has to do? We have to run the algorithm in your computer, like in your car. So where it collects all the data on the road and process it and should give you the final result. A car is there in front of you and it is stopped. Okay. Here you see that another thing is like each vehicle broadcasts its core state information in basic safety message. Like, let us say, you can say that like if devices are connected using Wi-Fi, and if I send my location and if others can receive, so device B can identify where I am, right? So like that, what's its basic safety message will be having? The car's location, car brake, if they apply the brake, that information will be there. What is his speed? What is his heading? What is his elevation? All this information will be sent every 100 millisecond, 10 times per second. Okay, so this frequency must be there. So you can ask me another question that can't we use Wi-Fi range here, Wi-Fi spectrum here, Wi-Fi protocol here? No, we cannot use that one. Wi-Fi is meant for high speed and for stationary devices. Even if you run with the computer for 10 kilometers per hour, you might not get the speed well. Okay, it is not for moving objects or Bluetooth also. Okay, but this spectrum, this standard is basically for 802.11p technology is basically for moving objects. Okay, low data rate, but very reliable, low latency, right? So actually, when I send the message, and if when it reaches other vehicle, if it takes 10 seconds, what is the use? By the time everything will happen, right? There should be less latency. The thing here, before we proceed, what are the main things we need to have? First thing is like update should be there. It's like frequency should be 100 hertz, you can say, or sorry, 10 msgs per second. Okay, and latency should be less. Okay, so compared to any other technology, either Wi-Fi or Bluetooth or Zigbee, so many are there, right? And RFID, RF, all these things, 802.11p is having low latency. Okay, so each one is having their own advantage. Wi-Fi is for main high data rate, Bluetooth also little high data rate, short ranges. Okay, and the third one is like a long range. Okay, long range. None of these wireless technologies can go more than 1 kilometer. I think Zigbee can go, but if I'm wrong, you can correct me. Zigbee can go around 1 kilometer, but none of the other technologies can go beyond 100 meters, 10 meters, also few things, right? But this technology can communicate around 1 kilometer. Okay, so updates, latency, it satisfies. Long range, it satisfies. Okay, so that is the reason we go for this standard. Okay. Any questions? Any questions so far? Okay, ma'am, any question session is there separately, or can they ask the questions when session is going on?
Yes, sir. At the end of the session, you can ask, or in between, you can.
Okay, okay, yeah, yeah. Okay. Fine. So there are some applications here. We'll come back to this one if we have time. And the problem here is, by this time, we have to identify the problem with this technology. That is, if I'm being telling that this car has to be having the special hardware, and this car also should be having another special hardware, VTX technology hardware. Let's say whatever the devices we are having so far in the car, adding to that another hardware must be there. If it is not there, then that is the problem with VTX technology. I mean, that is a main challenging. Like coming days, like a BS6 we have, right? The government should take action on this case. Like all the cars should be having this technology, then only it can work. If this car is not having that device, this car does not know whether this car is coming this way or not. It cannot see that, okay, because it doesn't transmit anything. Okay, so maybe you can hold this point. Okay, so this is one of the challenges in V2X technology. Okay. Okay, so so we can divide this V2X technology into two parts. V2X can be divided into two parts: V2V, vehicle to vehicle, and vehicle to infrastructure. Infrastructure means anything like a traffic signal or pedestrians, okay, or roadside units or toll gates, so many things. Okay, so to suppose if you are driving on the road and if there is a signal, you have to get the message, then only you can identify, okay, there ahead there is a signal. It is right now red signal is there. Okay, to know that this traffic signal should send the message, right? So it means the traffic signals, all this must be having V2X technology hardware. Okay, so I'm just putting the conditions, then only we can go ahead. Okay, so I told about car to car what information is passed always. Maybe you can also add some more information if you want. You can check on internet what are the information goes on BSM, basic safety message. BSM between the vehicle. I'm very bad at drawing. Okay, between the vehicles, BSM message is being sent. Okay, BSM means basic safety messages. All basic safety message will have all the information about this vehicle. Okay. And coming to V2I, what information it needs? Coming to V2I, it needs, let's say, my machine became slow. Okay. Let's say that again I'm drawing the intersection part. Okay. And we'll take two cases. Like road turning is there, little slippery. Okay, so here we can put one hardware. It always broadcasts that what is roadside information, RSI. So this road is little slippery, then go ahead. So that if any vehicle is coming in this way, he can reduce the speed. Okay, and you can say that there is a traffic signal. Okay, so traffic signal can broadcast the message to all the directions, saying that okay, lane information like these are the points. You can say road 1, road 2, road 3, road 4. Okay, so suppose if you're coming in this direction, first of all you should know which road you are in and which direction. Let's say this is A and B. Okay, so if you are there in A, you will get some other message. Okay, so it sends the information that okay, you if you are in this lane, you have to wait for 8 seconds. Okay, and if you are in this lane, suppose if you are in this lane, okay, you have green color, you can pass, you can go ahead. Okay, so all this information, right, it will send the mapping means the map information means what are the locations under 1A. So these are the points. So this is the latitude, longitude. If you are near to that location, then you are in road A1 and lane A. Suppose like that, it has to keep sending the information. It has to keep sending the information about the map, so that your car will identify which lane you are in. So that what you have to consider, whether you have to consider a red or green color, all this. Okay, all this information will be sent by RSUs. RSUs means the device, similar device, whatever the device you keep in the car, similar device will be installed near the road, on the road, or in mid of the road, so that it will send all this information. Map data is all about your road map. Okay, road information. SPAD is about signal phase and time, like when it will go, it will turn red or orange or green and all. Okay, roadside information, road safety messages. All this information is about whether it is a toll gate or a railway gate, all these things. Road safety messages means whether it is a slippery or whether water is there, or you avoid this road. All this information will be sent you using RSM. All this information, all these messages will be sent by roadside units. This data, right, will be sent one message per second. Okay, so any questions are there so far? Okay. Okay, so here is an example. Like you can see the traffic signal here. So it manages, if your algorithm is good, if your hardware is good, it will identify, it will give you some alerts, and it will let the traffic go smooth. Okay, and here you can see emergency vehicle. So it will let other vehicles to wait. This emergency vehicle will get the first turn. Okay, so all this. Okay, coming to the hardware. So really, the hardware, the general hardware looks like this. So the there are three main things. One is application processor. So far Babuji sir had explained about Raspberry Pi, right? In Raspberry Pi, ARM processor is used, application processor. So I think that is also Cortex A57 or 56, around that range only. Okay, so Raspberry Pi, how much it costs? Very hi-fi thing, maybe 4,000, right? So it will cost around 4,000. And the another device, which is a transceiver, transceiver which always sends and receives the messages. Okay, on 802.11, the range is, the spectrum is around 5.9 gigahertz. So this is the core part where it sends the data and receives the data. And this application process is like a computer. It will receive all the data and will analyze the data. And if you see other devices, right, can data, suppose if you see the car, you can see all these electronic devices, okay, ECU. So it will be connected to a CAN bus, RS-232, Ethernet, some flash memory and all, some other devices, some other peripherals, okay, and so that it will come to know what is your position and what is others' car's position, and then you have algorithms. Using that algorithm, it will give you an indication. So finally, this processor is connected to a screen, so where you will get the information, okay, all the alerts. So for each image, if any image or anything, if I take from internet, right, I've given the link here, okay, so it's not like a stealing something. So link is there. If you are more interested, it's like if you want to know more about hardware, you can click on this link and you can explore it a little more. Okay. Yeah, another third part is like a GNSS. So GNSS is nothing, the receiver is nothing but GPS transceiver. Okay, so it knows your location. It is very important to know your location accurately. Okay, so these three are like a very important thing in V2X hardware device. So it is common for the vehicle device and also RSU. Same hardware will be there. Okay. Any questions so far? Okay. So here, your GPS location, right, is very important to make these applications work. Okay. Suppose, you know, what is our GPS location accuracy we get? Maybe 2-3 meters, plus or minus 2-3 meters, right? If you're there in like a living room, maybe it can show that you are in another room or outside your house. Maybe radius, right, can be around 2 meters, 3 meters. Okay, so can we question here, will the accuracy, whatever the accuracy we get on our mobile, can we rely on that data? Just one answer I need. So I'll tell you about the importance of GPS. The importance of GPS is
Sir,
like,
one participant
yeah,
is very here in the chat box.
okay. Okay, sorry. What is hackability when sensitive data gathered from the card, such as location, driver's daily route, is exactly, this is a really good question. So people are worried, obviously, about your sensitive data. Somebody can track you, right? Suppose if you send the data, so in BSM, right, you have your ID. Okay, so I'm sorry, you have your ID, your location details. Okay, so that sir's concern is like, is there any chance that anybody can track your route? The solution in standard, right, it says that after every 5 minutes, your ID will be changed. Okay, every 5 minutes, your ID will be changed, and that is random. Okay, suppose from let's say this is your road, and from here to here, you have some ID 1, and here to here, you have some ID 2, here to here, ID 3. So if you have a constant ID, then somebody can track you. But the protocol changes your ID frequently. Okay, so that nobody can track you. Of course, we have to agree that suppose somebody is following you. It is a forest. It is forest place, and somebody is chasing you. In that case, yes, it is a problem. Okay, so I mean, he knows that on that road only you are there. But the thing is, it cannot. Your hardware, right, will not show where HVs, RVs are there, remote vehicles are there. It will not show on the map. If it is concerned, it will get you. It will get some alert. Okay. So what I mean, it's not like a Google map. It's not like Google Map where you can see some person on the road, one vehicle on the road, and you can follow. It's not like that. It should not show all that, all the information on your device. It will not show. If that car is concerned to you, like if it is coming to your direction on your same lane, and if you are about to hit that car, then only you will get then only you will get the alert. Okay. System is reliable with the concern with the sensor network hardware. Okay, question. You mean if sensors compromises, then things will go wrong, right? That is your question. Okay, great. Yeah. So, for example, if sensors can go wrong, by now many things would have happened. Let's say, in our car right now, everything is connected using electronic device. Suppose if you're rotating your steering, do you think it is connected to wheel? No, it is not connected to wheel. It is just your steering, right, is sending some information. I'm sorry, this is steering. So it is sending some information, your angle, your rotation, all the data to one electronic device, ECU. Okay, and this is given. It's like you can say some sensor. Okay, some sensor is there which senses your rotation, and it sends that information to ECU, and that ECU is connected to wheel alignment hardware, like you can say hydraulic hardware. So that where it will send that signals to that device where it will rotate your steel alignment. Tire alignment. Okay, so if let's say by now, if this sensor goes wrong, then by now many accidents would have happened, right? I mean, I'm saying already we are in soup. I mean, this is not the concern when you come to V2X. So it is already taken care. What I mean to say, if this goes wrong, then right now we have the problems. Okay, suppose if you apply the brake, it doesn't go to the tire brake directly. It goes to ECU. All these devices, right? It's all like a steering. Now, when you rotate it, just simulates that, oh, you are rotating the wheel, but not that. You're actually, it's like you can assume that in shopping mall, if your kid plays right, with the steering and braking and all, the similar system is there in your car. When you apply the brake, it goes to another signal to ECU. I mean, sensor is that it sends that to ECU, and it sends the signal to braking system. Okay, so this is all well tested. They will not compromise at all. Let us assume if you're on high speed, 100 kilometers per second, and if anything happens to this ECU, gone. Your braking will not work, your steering will not work, nothing will work. Your car just goes like that. Okay, so if there is still danger that if anyone can hack the system ECU, they can. They mean if they provide, they put some malfunctioned software in this ECU, they can control your car. Still, with whatever the cars we are driving on the road now, can be hacked easily. Okay, so but it is not so easy. You have to open the dashboard. You have to. There's so many circuits are there, and this program is not easy to replace. Okay, all these things are very basic, already taken care. Okay. Okay, that's really great question. Like relying on sensors. Okay, sensors accuracy. So this is already taken care, right? And another thing is I'm telling about a GPS. Okay, so GPS, whatever the GPS receiver we have in our mobiles is not accurate. It might give around plus or minus 2 meters accuracy, which is not acceptable for our cars. Because why cannot we accept that? So because suppose if you're traveling in this direction, if A is traveling in this direction, and let's say this width is around 6 meters, okay? So, but by some error, if it shows whatever is showing in green color, it is not actually your location. Red one is your location. But if it says you're going in this direction, then whatever the signal you get, right, whatever the information, actually this is two-way, one direction, two direction. If your car finds that you're going in this lane, and if you get, then in that case, this signal, right, whatever you get the alert will be completely wrong. Okay, so that is the problem. If GPS is not accurate, you need to have a special GPS device for your unit. Okay, so here there are some three levels of GPS accuracies. One is like if your accuracy as it is whatever you are having now, you can use that for, okay, you are going in which road, but not which direction, which lane and all. We cannot rely on that data. And if your GPS accuracy is around 1.5 meters or better, you can use for some other applications. Like you can say, we have listed so many applications, right? If your GPS is having 1.5 meters, maybe you can tick 2-3 applications will work. But if you have GPS accuracy 1 meter, then all the applications will work fine. That is why if you are manufacturing a device for V2X technology, you should get a better hardware for GPS location. You know, Gagan, anyone has idea about a Gagan, why it is there? Gagan project, you know, right? GPS aided geo augmented navigation. Very difficult to remember that full form. I written down. So, anyone has idea why do we need Gagan geostationary satellite for navigation, aviations for aeroplanes? Only the reason is to improve the accuracy of your aeroplane direction, how it is going, the location. Okay, so suppose if you see the aeroplane runway and all, right? Suppose this is your aeroplane runway. You can see some device here which looks like a small antenna. Okay, so it is used. I mean, as of now, whatever the satellites provided by US, you cannot get that accuracy. Like a runway is like this. If it is 2 meters or 3 meters accuracy, then maybe it will land on different location where it is very dangerous. Okay, exactly. You have to land at this location, at this lane. Okay, but if your GPS accuracy, I mean, if your aeroplane is completely automated, let's say, do you remember one incident happened in Mangalore? One aeroplane did not land where, did not touch the ground where it's supposed to. Okay, suppose here it has to touch the ground, but unfortunately it has touched the ground here, and it could not control the speed and hit the antenna and fell in the valley. Okay, that is the by human mistake. He I don't know whether it is a rumor or not. He was sleeping at the time before it lands. Okay, pilots. But if it is given, if it has to be automated completely by computer, then you need a better GPS location. As of now, while landing, human interaction should be there, all the aeroplanes. But if you want to automate completely using computer, I mean, aeroplane, around 90% of the load, right, is handled by computer. You just need to monitor. The pilots will monitor. In critical situations, they play a major role. But usually, they don't need to worry about anything. They can sit and keep monitoring how it is going. That's it. To cover even 10%, because of 10%, it is depending on human. Many accidents are happening. To reach this 10%, you have to have better GPS. That is the reason Gagan has this project, and with the Airports Authority of India plus ISRO, they have launched the satellites also. And in 2015, it was in calibration state, but I think now I do not know whether they are using that service. They started using the service or not, but that is for Gagan. Gagan is for that. Okay, so to improve the location GPS accuracy for aviation department. But what about cars? Okay, that is only for aviation. What about cars? You need to depend on some other companies. Okay, so few companies are there where they say that we provide a best GPS location. Okay, so any questions so far? Okay. Okay, so we'll proceed. Like a hardware, right? This is all about the standards designed for V2X technology. Okay, so first hardware will be there. You can correlate with the Wi-Fi. Okay, Wi-Fi or Bluetooth or any device which communicates. It can be your broadband signal also, DSL also. Okay, so hardware must be there where it has to modulate and demodulate the signals or the air, right? And it should listen on some particular band. Okay, and this is the standard 802.11p. This is what I've been telling that. So this standard says how your modulator or demodulator should work at a physical layer. Okay. And this is all about GPS location. To get the GPS location, CAN data, HSM is actually screen, which is connected to screen. Okay. So I'm little worried that are you able to follow or anything I need to explain a little more? Okay. So this is particularly related to V2X technology. Okay, this is all about GPS location. This is all about your car stats. Okay, this is like a display which is connected to display. Okay, So your hardware should contain all these interfaces with outside equipment, outside devices. Okay, and coming to so once you have reached the you demodulated the data. So how it should be proceeded? So there is another standard, and this standard, like zeros and ones you got. Some from this it will decode and you'll give the data to this layer. It's all about layers again. If you know about OSI layers or TCP/IP layers, like we have a physical layer, right? Physical layer, data link layer, network layer, transport layer, and application layer. Okay, so these two things, this one comes under physical layer, and this one comes under data link layer, and this one comes under network layer, and this one comes under, there is no transport layer kind of thing. You can say present session layer, and this one comes under application layer. Okay, so your hardware should support layer basis like this, and each layer has its own standard how to design their software. Okay, and at the end, this is like from this layer, right, you will get either a BSM or RSI or RSM or map, all the messages. You'll be getting a lot of messages to this application. Okay, this application will analyze all these messages. Finally, it gives alarm to the driver. Okay, so you can see the color coding, like blue is for US standards, yellow is for Europe, and green is for China. Okay, and this brown color, whatever is there, designed by our company. So they okay, so color codings you can see, and this is very good slide and more informative. If you want to do any research, right, you can study all these standards, how it works, and then you can enhance the standards. You can. Okay. Yeah, coming to, I've been telling about DSRC. Okay, DSRC stands for Dedicated Short Range Communication. Okay, so 802.11p is nothing but DSRC. Okay, so this is the spectrum range. You're all from electronics mostly, right? So like Wi-Fi, if you take Wi-Fi, it will be having some spectrum, right? And it will be having some channels and cellular network also, right? Similar way, around 5.9 gigahertz spectrum is allocated for this communication, and it is free. Okay, you don't need to pay to the government. Suppose if you need a cellular network spectrum, you need to pay, right? So for this range, you don't need to pay. It is actually reserved for safety applications, for vehicle communication. Okay. Okay, so there are unfortunately two technologies out there which can serve the same purpose. Like suppose this is one car, this is another car, and as I told you, these two sends the data on 5.9 gigahertz. Okay, and with 802.11p. Okay, so there are two technologies, DSRC and V2X. Sorry, CV2X. Okay, C stands for cellular, you can say. CV2X. So actually, DSRC is there from the beginning, but CV2X is emerging into this technology very rapidly, because it has some other advantage. Like DSRC is like, it can transmit the data between the vehicles, that's it. But if you have CV2X, you can have, between RSUs also, okay, but within 1 kilometer range, okay, more than that it cannot communicate. That is about DSRC standard. But coming to CV2X, there is another advantage. It's like a plus buy one get one offer. So why people are going for CV2X technology? Same range will be same, but suppose in case if you want to communicate your location details to the tower. Suppose you can say some hospital, ambulance is there, okay, and if you want to know the ambulance location in the hospital so that they can get ready. So mean this is hospital. You can say this is hospital, okay, and but its distance is high. You can say 5 kilometers. So how do you communicate? How do you let you know the hospital that where are you, and so that they can be ready, right? So in this case, V2X provides another channel, another adding to this, adding to communicating with your surroundings. It also provides another channel to communicate far further distances using EU. Okay, so a channel for, you can say in 5G or 4G, you can, it's like it is on different band. Okay, it is to communicate between your surroundings. You have to use 5.9 gigahertz, but if any information is there which you want to send very far distances, and you can use 5G or 4G technology where you send your data, normal data. Okay, you can use those ranges, between those ranges, to send some information to let your concerned people know that. Okay, so this is like another plus point if you use CV2X. Okay, both the chips are different. Okay, so now I've been telling about this one. CV2X, overview of CV2X is like this. So if they want to communicate with its surroundings, they can use 5.9 gigahertz. The channel that communication channel is called as PC5. Okay, and adding to that, it is like a complementary services. It's like you can also communicate with an E node B. Sorry, not EU. This is UU. Okay, where you can communicate with the cell towers, which is around 5 kilometers, 4 kilometers, like that, so that your concerned people will get the message. Okay, so we have this option. So far, it is not used, but if you design your hardware for CV2X, then this advantage you will get in future. Okay. Okay, so this is, I'm telling about the same thing. So DSRC and CV2X, both are for there for physical layer, and physical layer, either you can use DSRC or CV2X. So this is the growth. Okay, so whatever is there in orange color, CV2X, it is capturing a lot. So in 2018, it is almost DSRC. Now slowly you can see CV2X technology. CV2X, it depends on country. So China uses CV2X technology. US uses DSRC technology, DSRC, and they might change to CV2X again. Okay, so if you want more information, you can check in internet. So any questions so far? Got it. Okay, coming to attacks. So as Prasad sir explained, as told his concern about attacks and all, attacks will be there. Okay, so how do you mitigate them? So that is a more concern. I mean, as of now, even IoT also, we have a Hi-Fi hardware, better sensors. infrastructure is fine, but why it is not coming in reality as good as our mobiles and TVs and all other software things? It is about security, okay? And it is stopping a lot, okay? Because it can kill the person also, it can burn your house also. So those same concerns are there in automotive industry also, and it is more. Suppose there are a few attacks like a compromise on board. Suppose some virus is on there your computer, then it's gone. Spoofing wireless sensors. So let's say suppose this is actual signal, but attacker can keep his device over here, and he can send the information, wrong information, to all the vehicles, so that vehicles will get this information and will act on this one, which is wrong data, okay? So that he can disturb all the traffic, and also he can make more accidents, okay? So how do you mitigate this one? So suppose in internet also, if you send the data, password and username to Gmail server, some middle person can there, he can see your password and username on internet. I mean, he can run Wireshark, get the message and see your username and password. But how do you overcome that? Anyone can see that? Suppose this is your PC and this is your Gmail server, okay? And if you send password and user, you have to enter, right? Otherwise it will not give you the information. Some other middleman can plug his device and get your username and password. But how do you overcome that? I mean, okay, you might have heard about SSL, right? SSL is nothing but HTTPS. Okay, HTTPS is nothing like if you want to send HTML pages and all, right? We use HTTP protocol to share the information, okay? But it should not be plain text. So that we add HTTPS and SSL protocol to secure your messages. It will be encrypted, authenticated, and then the data will be sent to Gmail. Even if middle person plugs his computer on your internet channel, even if he gets the data, he cannot do anything with it because it is encrypted. And so the main thing here is like authentication. Authentication is very important thing. Like suppose if this person sends plain text to your car, let's say here, and if you rely on that without validating whether he's actual signal or not, then you are in soup. Should not do that. So when you get the signal, you have to identify, there is a mechanism called as authentication. Nothing but it comes from the actual signal or not. There is a mechanism, there is a protocol, SSL, related to SSL, which will let you know whether he is a real person or not. Okay, in that case only you allow it, otherwise don't allow it. Okay, suppose if this person is sending messages again and again, you can block him. Okay, so all this is possible using SSL. It's so much research is going, and it is already implemented mostly, but some other concerns are there. It is going on. Okay, if you are interested in SSL technology, secure cyber security and all, you can concentrate on this challenge. Here, why am I enforcing the points and challenges? It's actually the area where you can research more. Okay, so in real-time sensors, how do you make sure the messages are secured? You have to use some security mechanism. Okay, so in our Gmail messages and all, we use HTTPS. Is there anything for IoT devices? Yes, there are. So what are those? you can do a lot of research on that. Okay, and it is recent topic. It's not something very old. You can get so many ideas. Okay, so what other challenges there? Need a lot of cooperation. Like as I told you that all the devices on the road should be having this technology. This hardware should be there. Okay, so if it is not having, what is the problem? So these are all the challenges you get. And coming to need for cooperation, like stakeholders, automotive, who is manufacturing the cars, and the software and hardware and software developers, traffic management system operators, telecommunication companies, all they have to gather together, and then they have to design this technology. Okay, so as of now, it is in very good shape, but still some more. It's like, right? Suppose I can write one software which is similar to Gmail server, because I need to be only a software engineer. That's it, not more than that. So I can do that. But if I depend on some other entities, like between these two, cooperation is required. You know how much time it takes. Let's say our government actions. Okay, like if you go for anything to the government office, it will take a lot of time. I'm not blaming government, because there are so many protocols, right? They have to pass to some other superior, so many things you have to do, right? That is the reason it gets delayed. But if you go to private company, they make that channel little fast, right? So now all this to make happen, you have to depend on government. That is the problem. Okay. So another thing is spectrum availability. It's not a big concern. It is already free. And deployment constraints. This is also not very difficult thing. You can do that. But whatever is highlighted here in yellow color are actual challenges where you can do a lot in this case. Like, you need more standards in cybersecurity. What I told, right? Some other attacker can send duplicate messages, some other junk messages, and we should not rely on that. Your car hardware should be having intelligence to avoid those messages. There should be some standards. Everything should be connected. Everything, again, I'm telling you, all the devices should be using this V2X. That is really very difficult. And testing is more challenging. It's like they announced in 2015 that autonomous driving cars will be there by 2020. But now we can't see that. What is the problem? There are a lot of problems. In 2 years back, you have seen that a vehicle, right, used by Uber to perform self-driving test hit and killed a woman crossing the street in Arizona. I mean, there are many incidents. You might have heard about Tesla car also. It just rammed into the stopped truck. Okay, so there are so many incidents happened, and they came to know it is not so easy to make it real. Okay, that's why now if you ask same companies which announced in 2015 that 2020 it will come by autonomous driving cars, but if you ask them now, they are not sure. Maybe they cannot say even after 10 years also it is difficult, because a lot of things, your roads have to be more modernized. You especially in India, you don't see signals well, and road units and all. It's very hard to see the lines on the road, first of all. Okay, so so many concerns are there. Developed countries are okay, but what about developing countries? It's really hard. Okay, in developed countries itself, we can see these many incidents. What about our countries? Okay, so it's not so easy to make it happen. It's not like your mobiles or TVs or something. It is actually playing with our lives. Right. So after this incident, right, so many companies which are working for autonomous driving cars lost their market value. a lot, 10% of its market value with one incident. That's it. Okay. Sometimes they can go to jail also. Okay. So the conclusion is like, if you have to, if you say that you completed your hardware for autonomous driving cars, I'm saying autonomous, okay? V2X is still possible. It will come and hit the road within 4 or 5 years in India also, okay? And it is almost all there in China and the US. They're already running trial versions and all. But autonomous, I'm saying about this one is mostly about autonomous driving cars. Okay, so you know, to say that your autonomous driving car works well, to accomplish that statement, you have to run your car for 8 billion kilometers. Okay, 8 billion kilometers. You need to run your hardware for 8 billion kilometers. If there is any bug fix, usually in software there will be some issues, right? In software, so if you fix anything, you have to start from the beginning, right? 8 billion kilometers means, I just calculated, it will take 27,000 years if you run a car on 5 kilometers per hour every day, 24/7, 27,000 years. How do we achieve this one, right? So it is accepted by Google and some other companies. The race began. Waymo, it's a Google car. So, I mean, they integrated a company, Waymo, and it is subsidiary company of Google. So they are running 25,000 virtual cars. Okay, and Google has a lot of information, right? We know that because they have Google Map, all the data is there. They know that, what is happening in Vizag, a particular road. They predict it now. Or how much traffic will be there, right? So they have a lot of information, and it is very good for them. Like they can only test this autonomous driving car software well, and they're running 25,000 virtual cars 24/7, simulating 13 million kilometers per day. Okay. So this is also a very, very big challenging thing where you can do a lot of research and how to simulate virtual cars. You can write your software and make like a virtual car and keep running that with road information. Okay, so many interesting research points I have given here. Not only this, there could be something else while making presentation. I've collected few of them, and maybe I think it will be helpful to you. And some other references, which helped me to make this presentation, and some other information you can get from these links. Okay, before I say thank you, I'll be very happy to clear your doubts. You can ask me anything. If something is not clear, if you feel something in your mind is better than this one. For your research points, definitely these links will work better. Okay, so, and I will be available on Gmail, and you can ping me. You can send a message on this mail ID. Definitely, I will reply to your queries, or if anything is there, any point is there, I'll try my level best to clear your doubts, or if I'm helpful to you in any case, I'm really happy. Okay, so let's see, any doubts are there. And some other challenges are there, like if your car goes into a tunnel, in tunnel, you will not get a GPS locations well. I mean, uh, you can search for the papers in tunnels. How do you make sure GPS location is better? Okay, and in traffic, let's say heavy traffic is there, your computer, your hardware device cannot process more number of messages. As of now, one car can process 20 messages per second, sorry, 2000 messages per second, means it can analyze 200 vehicles of your data surrounding to you. More than that, it cannot. So is it good to give 2000 messages to the hardware? Can you make any filtering? Right, in heavy signals, right? You can get a signal from 200 vehicles definitely, and your hardware will be on load. So it will be too much. So you can control some signals near the physical layer, depending on maybe a signal strength or the distance that vehicle, the distance between vehicles. So using all that, you can avoid that traffic. Okay, so okay. Yeah, hello.
You elaborate what are the research problems which are available in this area?
Sorry, sir. What are the problems?
Research problems which are in this area.
Okay, yeah. So that is what you can say, that security thing. Okay, how do you make sure the signals whatever you receive from the authenticated devices, like you can see, you can search for the standard okay, you can search for this standard to IEEE 16009.2. Okay, there is a standard, but not able to, this standard is not enough. It's like, as I told you that, let's say your car is there, it is receiving 2000 messages per second. Okay, so first thing, you cannot uh, put a hi-fi server in computer, in your car, right? You have to run all your software on hardware like Raspberry Pi. So if you need to process these many messages per second, and not only processing, before this, you need to authenticate. Authenticate means you need to check each message. There is a mechanism called SSL. SSL protocol is there. Using that, you can authenticate the person, the message, whether it is correct or not. After that, you need to process it. Okay, process, and then process means what are the data you get. You can get what are the values are there, like longitude, latitude. It's like, you can say that process is nothing but decoding. After that, your application will get all this latitude, longitude from multiple cars and develops one alert. Okay, so at each stage there is a challenging point. One is, main thing is like, first level at the physical layer itself, congestion control. Congestion control means, if whether it is really required to process 2000 messages per second, can you avoid the number of messages to process it? According to the protocol, if your car is there here, if 2000 messages are coming to your car, you need to process it. But can you tailor that, and instead of 2000 messages, can you tailor it to 1000 messages per second? This is a congestion control. This is nothing but congestion control. Like let's say the cars are there. If the car is very far, so maybe you know this car is not concerned for you. Okay, you can avoid this car. Okay, and maybe you can avoid this car also. Maybe you can consider this cars which is very close to you. Okay, so there are some algorithms, and maybe you can check that congestion control in V2X technology. Still, the research is going. So many problems are there, and this is one challenge. Another challenge is about GPS. If you are there in tunnel, so you are there in tunnel, you are there in valley, or some other locations where GPS signal can go wrong, that the location, the accuracy can go wrong. In those cases, how do you overcome these problems? Okay, tunneling issue, you can say, like a tunneling issue in V2X technology. Okay, another thing is like security concerns. I mean, cyber security in V2X, cyber security. Okay, cyber security in V2X technology. This is one challenging and research for. Still, so many people are struggling because of this one. So you can come up with, you can join in the group, and you can derive some algorithms. Okay, so coming to applications, here you can use machine learning algorithms or AI. Some algorithms are there, like let's assume your car is all these cars, right? All these cars, you'll get latitude and longitude. So you need to track this car. Suppose if you are going in this direction, okay, and you are following this car, okay. So you need to track how this car is, the moment is. If it is, this car is taking a turn, some curves are there, you should slow down, right? So all these algorithms are there. So you can say that applications over V2X technology. Okay, so applications, and their applications, they use a lot of algorithms. You can study those algorithms, and you can use the ML or AI. Sorry, it is fourth thing. You can use algorithms, whatever is existing. You can tune them, or you can introduce machine learning or artificial intelligence and make your application better.
Sir, there is one more question, sir.
Yeah.
It is from a participant.
Okay.
Sir, what if the network is loosey, that is, the signals are not transmitting or not being received?
Oh, yeah. In that case, let's say you can have some other intelligence, like if you are not getting the signal, you should get some alarm on your dashboard that you lost V2X connection or board, okay, or some modem you lost. So it is you have to take care of all the precautions. I mean, losing the network did not happen, I mean, will not happen very often, or it will not happen. It is very rare condition. That is what I'm saying. Let's say losing, because this is between the cars, right? This is between the cars. And if you feel that any line of sight, some problem is there, will be there, but it is very negligible. So I mean, losing the network signal is very rare thing, which is not concerned. As of now, we have seen that will not be a concern. We have the standard body, right? They choose this spectrum and the standard to make sure always there is a signal. I mean, there will be no loss of the messages.
Okay, sir.
Yeah. It's not like our internet connection or Wi-Fi connection. So it is tend to lose. I mean, it is bound to lose. Sometimes connection will go wrong. And this is a broadcast. It's not like your internet connection. First establish the connection and send the data. It's not like that. You just keep receiving the messages. It's like a UDP, and not like a TCP. UDP. So very, very less concern thing here.
Okay, sir. Thank you, sir.
Yeah.
Sir, if there are any more questions from participants, we will mail you, sir. Actually, we are running out of time now.
Yeah.
The next session should start by 2:30. We should give a break time for participants.
Lunch. Yeah. Okay.
So, any further questions from the participants, and they can, we request you to post it in the chat box. We'll mail it to the sir, and we'll get back to you. Over to you,
Sure,
Annie, ma'am.
Thank you, sir. On behalf of Department of PCE and our participants, we wanted to express our appreciation to you for this online FDP. As our speaker, on the topic Internet of Vehicles, sir, this is very new technology and limited work is available on this topic. The main reason for car accidents is human error. Fortunately, this number could be reduced through IOV Internet of Vehicles technology. And this session is extremely informative and helpful to those who are currently working in this emerging area, sir, and for PhD aspirants too. Thank you, sir. Thank you so much for accepting our invitation.
We request the participants to please enable your cams for a small photograph with I would like to take a screenshot. All the participants, whoever can enable your cams, please enable it. Thank you.
Okay, thanks. Thank you, one and all,
Thank you,
for
thank
giving
you so
me
much.
good
Thank you, sir.
opportunity.
Thank you, one and all. Again, we'll meet you at 2:30 p.m.
Thank you, sir.